All right, so heading into chapter 10, which is looking at gases and gas laws and kind of their behavior. So when we talk about gases, they have some different characteristics compared to liquids and solids. So one thing is that gases expand to fill the container that they're in. So if you have a small canister and you release that air into, or whatever, that gas into a larger vessel, it's going to expand evenly throughout that whole space eventually. Gases are really highly compressible. You can compress them down and pack in a lot of gases since there's so much space within a gas. And then they have really obviously low densities because they're gases. They take up very little room. Now, something that we're going to refer to a lot in this unit is the idea of pressure. Like, what is pressure? And pressure, like simple terms, is the idea of force per area, or the amount of force that's exerted on a certain area. Now, how that applies in chemistry, and specifically with like gas laws, is thinking about atmospheric pressure and the idea that the atmosphere where we live, like in Blaine, you've got a certain amount of air that exists above you, okay? And imagine like a column of air, as diagrammed here, column of air going from where you're standing all the way up to the outer atmosphere. And that column of air is, gravity is pulling on those air particles, and they push down with a certain amount of force. The force gets greater the closer you get to the surface of the Earth, because there's more air particles packed in near the surface of the Earth versus up at the top. So atmospheric pressure is this weight of air per unit of area. So we use atmospheres or millimeters of mercury or torr often to refer to pressures, at least atmospheric pressure. And then as well as you have a Pascal. So one Pascal is equal to 1 Newton per meter squared. So there's your force, 1 Newton per meter squared, which is your area. A bar is 100 kilopascals. And we'll look at some other units. Well, here's one. So another form is millimeters of mercury, or torr. And these are basically defined by the amount of change in millimeters of mercury. So when let's say you take a pool of mercury, so you've got this dish of mercury, liquid mercury metal, very dense, very heavy, and you fill a tube of glass with mercury as well. Okay, so the whole tube of glass is filled with mercury. And if you invert that tube of mercury, the mercury, being as heavy as it is going to pull and try to basically leave the glass tube. But since there's nothing to replace the space above it, the mercury doesn't fall all the way out. And so you get a space above the mercury that is a complete vacuum. There's no gas, there's nothing in there. It's void of anything. And what happens is that if the atmosphere is pushing down on the pool of mercury. If the atmospheric pressure increases, so there's more pressure pushing down, then the level of the mercury is going to go up, because the atmosphere is pushing down on that mercury, and the mercury is going to go up into that vacuumed space of the mercury. Now, let's say the atmospheric pressure is low, so the atmospheric pressure decreases, so there's not as much atmosphere pushing down on that pool of mercury. Well, then the mercury level is going to lower. Okay, it's going to go down, and so you're going to have a decrease in millimeters of mercury. So that's a device that was developed to measure atmospheric pressure. We actually have a nice standard barometer in the science lab that has this. It has a pool of mercury down at the bottom. It's closed. It's not like this giant dish with a bunch of mercury metal kind of floating in it, but you have this pool of mercury and then a glass tube that's connected to it. So another relation is that, so 1 atmosphere pressure is equal to 760 torr or 760 millimeters of mercury. So that would be kind of those relationships. And then those would all be equal to 101.325 pascals. So another way to measure pressure is using a manometer. So a manometer measures pressure, but rather than measuring atmospheric pressure, we're probably measuring the pressure of a specific gas that's in a container. So our example here is we've got some gas in this vessel, and it then has this tube that has some mercury in it. And before the gas was released into this tube, the mercury was level. They were level with each other. Well, we know the pressure that's pushing down from the atmosphere because you can use a barometer to figure that out. And so the difference in height from where the atmospheric pressure is pushing versus the gas in the chamber is pushing, we use that to then determine what the pressure of the unknown gas is, which actually works out quite well in determining that. And you'll have some practice problems related to thinking through like how a manometer works. One thing that'll come up often is the idea of standard pressure as well as standard temperature. But standard pressures are based at 1 atmosphere of pressure. So basically what normal atmospheric pressure at sea level is called standard pressure. And it's equal to 1 atmosphere or 760 torr or 760 millimeters mercury or 101.325 kilopascals. And those are just units that you should know. Just know them. Have them fixed in your brain. All right, and that's it. That's just kind of our introduction into the idea of gases and pressure, and we'll go further into what it is in class. Thanks.